right. So today I'm going to take a look at the final exam from fall 2017. Okay, this is question 8. Okay. In this particular one, we're looking at a Taylor polynomial. We want to center this at a equals 1, so it looks like it's a third order they're telling us to do. So our question looks like this. Let me set in focus. Okay, good. All right, so we want to be able to find this. So third order Taylor centered at x equals 1. Okay, so keep that in mind. So now what we're going to do is we're going to set up, first off, we're going to write out what our generic form is going to look like. So remember, that's going to be f, our function evaluated at 1, so x equals 1, right? That's where it's centered, plus our first derivative evaluated at 1, times, I'm going to go x minus 1, right, all over 1 factorial. So x minus 1 to the first power, plus my second derivative evaluated at 1, times x minus 1 squared all over 2 factorial, plus my third derivative evaluated at 1, x minus 1 to the third power all over 3 factorial. Okay, so this is our general form, okay, for our Maclaurin polynomial, right? And we're going to be looking for these coefficients here. Function f prime, f double prime, f triple prime, all of it evaluated at x equals 1. Okay, so let's set up our table for this. So this is my function. I'm going to say x is equal to a, which is equal to 1. Okay, so on my zeroth derivative, this is just my function itself, which is equal to, oops, I forgot to write that down. The function itself is equal to the natural log of x. So that's what we were given. Okay, so the function is equal to ln of x. Okay, so now the function evaluated at 1 is equal to the natural log of 1, which is equal to 0. Okay, so this is my first term here, which is going to be a 0. Okay, so I need to take the first derivative. Okay, so my derivative of natural log is 1 over x, which I'll also write as x to the minus 1, just so that we can see it. My first derivative evaluated at 1 is going to be 1 over 1, which is equal to 1. This number here goes into this coefficient form right there. My second derivative, right, is my coefficient, minus 1, x to the minus 1, minus 2. So this is minus 1 over x squared, is what we're looking at. F double prime evaluated at 1 is going to be minus 1 times 1 over 1, which is just equal to minus 1. This number here goes into this coefficient form. My third derivative, right, I've got a minus 1 times a minus 2, x to the minus 3, I have to subtract one more, which is going to be the third derivative evaluated at 1. This is positive 1 over 1. This is going to be 2 times 1 over 1. So this is just positive 2. This number here goes into this coefficient form right there. Because we basically have everything that we need in order to fill out our Taylor. I know I can read ahead. So the next part of it says we want to find the upper bound on the error. So we're looking for the third order error, which means I'm going to need my fourth derivative. So I'm just going to calculate it here while I'm here. Okay, so I'm going to get minus 3 times minus 2 times minus 1, x to the minus 4. Okay, and I'm not going to worry about evaluating that. Actually, let's go ahead and we'll multiply this. So I'm not going to evaluate that at a equals 1 or x equals 1 because I'm going to use this in my error calculations to calculate my z. Okay, so this is negative times negative times negative. So this is minus 6 all over x to the 4th. This is what we're looking at for our fourth derivative. Okay, so keep that in mind because we're going to use that later. Okay, so let's go ahead and write out our Taylor. So, Taylor centered at 1. Okay, so I'm going to start filling in the blanks for what we had. Let's see if I can try to zoom out too much. All right. Okay, so my first one, that's going to be 0 plus my f prime plus my double prime minus 1 minus 1 squared over 2 factorial plus my third derivative over 3 factorial. Okay, which you can clean up if you want to. You can leave it like this. It's totally fine. So I'll kind of put an underline on it right now. Don't feel like you have to make it look pretty. I will totally accept that. That's an acceptable answer. But let's go ahead and multiply it out so you can see what it looks like. X minus 1 minus x minus 1 squared all over 2. 2 factorial is just 2 plus 2 all over 3 factorial. 3 factorial is 3 times 2, so the 2's cancel. X minus 1 cubed all over 3. Okay, so this is correct. This is also correct. This is just a simplified version of that one. That gives us our answer for part A. This is part A of the question. Okay, so part B of the question says let's come up with the error. Okay, so we're going to be able to find the error for that. And what they're looking for, they kind of give us some bounds on this. They're trying to stimulate us and kind of trick us with this question. So we've got x minus 1 is going to be less than or equal to 1 over 5, which is really just 0.2. Okay, so they're kind of giving us a wider range around where we're centered. So we're centered at x equals 1, and we're looking at some plus or minus 0.2 around there. Okay, so remember our error. Our error is going to equal to the max of our fourth derivative, because it's third degree n plus 1, evaluated at some z value, times we're going to go x minus 1, which is absolute value, x minus 1 to the fourth all over 4 factorial. Okay, so this is the formula that I need to fill in the blank. Okay, this part here, they gave us already as 1/5. I'm going to substitute that in later. This part here I have to figure out. I have to do some legwork to figure out how I'm going to calculate that. So the first thing I'm going to do is I'm going to go back to my bounds here. Okay, so I'm going to go minus 1/5 is less than or equal to x minus 1, which is less than or equal to 1/5. Okay, I need to solve for an x value so I can figure out what to plug in on my derivative here. I'm looking for a value here on my z. Okay, so what I'm going to do is I'm going to add 1 to both here so I can get some kind of value for that. So 1 minus 1/5 is going to give me 4/5. 1 plus 1/5 is going to give me 6/5. Okay, so now I want to be able to choose a value for x that's going to maximize what I'm trying to do. Okay, so there's a couple of things I need to think about. One of them is, I'm not quite sure, right? I'm going to go back to my fourth derivative here, is basically a 1 over x to the fourth. So I've got this x to the fourth function, right? So when I look at x to the fourth, right, my x to the fourth is kind of going like this, right? And I'm looking at a value, I'm looking at something centered around 1. So here's my 1. This is where our function is being centered. So somewhere around 1, right? And this is my 1 over x to the fourth. So my x to the fourth centered around 1. This is a decreasing function. Okay, kind of doesn't make sense to look over here because our natural log isn't defined. But just for all intents and purposes, our derivative is a decreasing function along this interval here, which means to maximize my value, I have to choose the lower end, okay, of my boundary here. Okay, so I'm going to choose 4/5 as my z. Okay, so my 4/5 becomes my z value. That's the thing that I'm going to plug into my derivative. So let's go ahead and start filling out this part right here. Right, so my max, right, is going to look like absolute value minus 6 all over z to the fourth times x minus 1 to the fourth over 4 factorial. Okay, so let's start plugging in here. Okay, so we already chose that, so that's going to be minus 6 all over 4/5 to the fourth times x minus 1 to the fourth over 4 factorial. Okay. So let's start working things through. The absolute value and the negative is going to make that go away, right? So we're looking at going to be 6 all over 4 factorial times 1 all over 4/5 to the fourth times, right? This value here gets substituted based on the parameters that they gave me at the beginning here. So I'm going to substitute in 1/5 to the fourth right there. Okay, so I basically get to multiply everything through, right? And then see what I get when I do that. When I multiply everything through, and watch out because this is 1 over 4/5 to the fourth power. Just to make sure that you have all those things correct when you're setting that stuff up. Okay, so 1 over 4/5 to the fifth power is going to give me roughly 0.1239776. Okay, as an error. Is the error for my third degree polynomial, Taylor polynomial. Okay. The hardest part, right, was figuring out what I was going to choose for my z value, and I had to be able to evaluate based on the interval that they gave me right here. Okay.